Dear civil engineers, professionals, academicians, researchers, road makers, today I seek your attention regarding the following matter. Do you think in the present era of highway construction, spending of lakhs of crores of rupees in highway construction using flexible payment method as per IRC 37 is worth to eliminate premature failures of riding surface and to ensure rutting free surface? Let us examine the issue for your kind appreciation. It is a very practical and sensitive issue facing today highway sector in India, because India is indeed spending lakhs of crores of rupees on the Bharatmala, PMGSY, expressways and stateways, etc., all mostly built as flexible payments as per IRC 37 2018. Let us see the realities, limitations, and worth of money spent on highways. First of all, we will see why India prefers flexible payments mostly as per IRC 37 because of lower initial cost compared to rigid payments, faster construction speed as it suits large scale expansion. It is easier repair and overlaying procedures need not be stopped traffic, and lastly widely availability of local materials because of our geography, bitumen and aggregates. These are the reasons why India is adopting mostly flexible payments. If you see the design standards, we are adopting IRC 37 2018, which provides a clear mechanistic empirical framework. The basic principle is fatigue at bottom tensile strain of DBM layer plus rutting at subgrade compressive strain. So, from a network expansion perspective, the choice is justified, but the problem of premature rutting is the common in Indian highways all over the country. You can check the status at field level. Despite IRC 37 compliance, premature rutting is widely accepted and common in Indian highways. So, the probable reasons could be, please guess what could be. In my opinion, first is the structural design gaps. If you examine the IRC 37, rutting check is only limited to a subgrade compressive strain criterion only. But rutting within bituminous layers, BC or DBM shear flow, is not directly checked in designs. It is handled only via mixed designs, wheel tracking, test, etc. very high axial loads, that is overloading by trucks, not fully accounted for in traffic estimates. This is the reality, and this is the design gap. Second issue is the material issues. Bitumen softens at high pavement temperatures in summers of regions, especially in South India and parts of North India also. At this high temperature, mixes becomes unstable because use of poorly graded aggregates or rounded river gravels. Naturally, there is a loss of interlac, causing shear rutting. Inadequate use of polymer modification, either crumb rubber or polymer rubber, or anti-rutting additives in many projects. These are the material issues. And third is the execution or maintenance issues. During construction, we observed improper compaction of pavement layer results in low density leading to plastic flow. Weak bond between BC and DBM is the second major lapse. Because of this, slippage rutting occurs. And most predominant factor is the poor drainage. We will construct world-class roads, but we never thought of drainage. This poor drainage we can subgrade by penetrating through various sources, and it will accelerate deformations. It's also a maintenance backlog. We will neglect and will wait till rutting accumulates and never bothered. This is the practical and what is happening at site. Now we'll examine under the above conditions, is the massive investment worth it? I'll say yes, because flexible payments allow India to achieve rapid network growth at manageable cost. Overlays and periodic renewals are possible without full reconstruction. And IRC 37 is among the most updated design codes globally. So the other factor is arrest of rutting, because IRC rating criteria is incomplete, because it ignores bituminous layer rutting. The code forgot about the bituminous layer rutting. Indian climate having high temperatures, monsoons, coupled by overloading, is considered as very aggressive environment to the flexible payments. And without strict quality control, enforcement of axial load, overloading, and without use of advanced mixes, rutting is unavoidable. This is the reality. Then what is the way forward to ensure rutting free surface? The first thing is material improvement. Wide adoption of polymer modified binders. Crumb rubber asphalt. Use of stone mastic asphalt for heavy traffic corridors. Mandatory wheel tracking. Hamburg wheel test performance specifications for BC and DBM. Then second is the design improvement. It should include shear strain criterion in BC or DBM in a IRC design checks, not just subgrade compressive strain. Nowadays, rutting is happening in BC or DBM layers. The criteria of subgrade compressive strain is inadequate. We need to see layer-wise rutting prediction models. We shall develop a design criterion to evaluate layer-wise rutting prediction models instead of subgrade. Better calibration of traffic loading and climate conditions. And third is the execution and enforcement is the most important. We have wonderful engineers, administrators, and qualified contractors. We all with combined effort, we can achieve quality control and proper compaction, binder content between bituminous layers and adequate drainage. It's not a big task. And the administrators shall control axial load regulation. Without strict enforcement of overloading, any design fails. Regular preventive maintenance, thin overlays before distress escalates. These are some of the enforcement factors to be implemented honestly, not for any shade. So the conclusion is India's investment in flexible payments as per IRC 37 is worthwhile for connectivity and economic growth, but does not guarantee rutting free surfaces. This is the hard reality. To ensure rutting resistance, IRC criteria need enhancement. That is layer-wise rutting. Mixes must shift from volume-based to performance-based, and execution or enforcement discipline must match design intent. Only with these three better design checks, advanced materials, strict construction or traffic discipline, we hope, India hope, to reduce rutting and protect its trillion rupee highway investment. For this, our policy, we should formulate proper policies and message it to the stakeholders. So I'll briefly explain what could be our policy. To make India's highways truly durable and rutting free, IRC 37 must evolve, moving from subgrade only rutting checks to layer wise performance based rutting design, backed by material innovation and enforcement. Present scenario in India and shortfalls. As I explained above already, one is the theory behind flexible payment design is million standard axles versus CBR. Basic concept in the design is in flexible payments, wheel loads are transferred from surface to base, base to subbase, subbase to subgrade, mainly by grain to grain contact and layer action. The subgrade CBR indicates the strength or stiffness of a soil, that is, how much it resists penetration deformation. The million standard axles indicate the traffic loading, that is, cumulative repetitions of a standard axial load. So, MSA is demand and CBR is the supply or support. So, this is the basic principle behind our flexible payment designs. Now, we will see the relationship of MSA versus CBR. As you know, IRC 37 uses a CBR versus traffic chart. Higher MSA, thicker payment needed. Higher CBR is a better subgrade. We need thinner payment. So the formula is simplified, is a conceptual form of payment thickness is a function of MSA and CBR. This is the main philosophy behind the payment design. Never think the design philosophy, how it is reflecting actual load transfer at site practically. So practically yes, but not fully, because the CBR test is a simple empirical penetration test. It does not directly measure actual wheel load transfer mechanism, stress, strains, fatigue, rutting. In actual transfer of load from grain to grain is hypothetical only. It is not practical. So what it reflects Subgrade resistance against penetration under a standard plunger, which is useful for low medium volume roads, but not for highways having large volumes of traffic. What it missing in the design? Effect of layer modulus and elastic properties of bituminous base layers is missing. So stress distribution using Bosene or layered elastic theory, cumulative fatigue and rutting under repeated loads, temperature, moisture, aging effects on materials. That's why IRC 37 2001 onwards, especially 2012 and 2018 versions, move towards mechanistic empirical designs. Loads causes strains in the critical locations, that is bottom of bituminous layer and top of subgrade. The design philosophy changed to this mechanistic empirical criteria is an improvement over the grain to grain transfer. Now we'll see the performance criteria of this mechanistic empirical design criteria. So in this fatigue cracking due to tensile strain in bituminous layer, rutting due to vertical compressive strain on subgrade. This is the philosophy. And in this, the properties of BC or DBM rutting criteria is not taken into account. This is somewhat missing. So its a practical implication is for rural roads and low volumes, CBR method is adequate, empirical, quick and economical. For national highways and expressways, mechanistic empirical design is preferred because it models actual load transfer and fatigue mechanisms. So MSA versus CBR charts will give simplified empirical tool. Mechanistic empirical design using resilient modulus and strain criteria is closer to actual load transfer compared to grain transfer. But the lacuna is rutting is not considered in the BC or DPM layers. So in summary we can say MSA versus CBR method is empirical and only approximates the load transfer mechanism. It reflects subgrades' ability to bear loads, but not the true stress strain distribution in multi-layer pavement. For realistic load transfer, layered elastic theory plus fatigue or rutting criteria, as in latest IRC 37, is the correct approach. So, there is a need to revisit rutting criteria and flexible payments And we should see the role of bituminous layers in rutting. Here we will see the problem with the current IRC 37. The current mechanistic empirical design assumes rutting is primarily governed by vertical compressive strain at the top of subgrade, which is not adequate and neglected what is happening in BC and DBM layers. Rutting within bituminous layers is handled only via laboratory mix tests such as wheel tracking, Hamburg wheel, Marshall stability. We are not bothering about the stress mechanism happening in BC or DBM. However, field evidence shows permanent deformation in bituminous layers dominates in many highways, especially under high pavement temperatures, heavy axial loads, thick bituminous overlays. Is the actual at site. This gap indicates that rutting in bituminous layers is underrepresented in structural design criteria. So, in order to improve our design philosophy or design criteria, we need further research. The objective shall be quantify the contribution of bituminous layers versus subgrade to total rut depth. We should see the role of bituminous layers. And second is we have to establish mechanistic shear vertical strain criteria within bituminous layers for rutting prediction. And third is that we have to develop or improve a layer-wise rutting model that integrates BC rutting, DBM rutting, subgrade rutting, all three combined. Then only we will get the actual site model. So for this, we have to design, we have to recommend for incorporating bituminous rutting into IRC or mechanistic empirical guidelines. Then only this problem is represented properly. Now here hypothesis is rutting in thick bituminous pavements cannot be predicted reliably by subgrade compressive strain criteria alone. A mechanistic parameter correlates more directly with observed rutting in asphalt layers. For this, we can develop some methodology. In this, the first thing is review of literature. We have to review IRC 37, ASTO, ME, Shell, Astrodes is the models adapted during various parts of the world. Rutting models. So collect Past studies on asphalt shear strain criteria, viscoelastic plastic rut models, and field calibration work. So for this we need field studies. We have to study at field mostly because literature is not available. So for this we have to test some sections. Select 2 to 3 highway stretches having different climates, traffic levels. Preferably include both rutting dominant and cracking dominant failures. And we have to do instrumentation. Multi-depth strain gauges. We have to install in BC, DBM subgrade at 3 levels. Thermostats for bituminous temperature profile. Deflection measurements using FWD. We have to establish these instrumentations and how to monitor at site with the above instrumentation. Periodic rut depth surveys using profilometer or laser. Traffic loading data. We should see the traffic pattern and how loading is running on the road. And thirdly, laboratory studies. For this, you prepare asphalt mixes identical to field sections, not laboratory, and conduct wheel tracking test to measure rutting susceptibility, dynamic creep test to obtain permanent deformation characteristics, repeated low track cell test for granular and subgrade materials, complex modulus fatigue tests for mechanistic inputs. These are the laboratory studies to be conducted. So then we have to develop model. In this model we use layered elastic and finite element models like Kenpave, Bizarre, Everstes FE, Abacus. Compute tensile strain, fatigue, and compressive strain at subgrade rutting. Compute shear strain distribution within bituminous layers. This is the important. And use an empirical mechanistic equation to find out cumulative rutting across all layers is a function of shear strain in BCR DBM, shear strain subgrade, pavement temperature, and load pattern. Is a function controlled the cumulative rutting across all layers. This is the empirical formula we have to develop. And we have to see the relation. So in reality, rutting is the sum of contributions. It's a summation of rutting in BC, rutting in DBM, rutting in subgrade, and rutting life of payment is controlled by the most critical layer. So this is the philosophy. I need more research. So after establishing the relation, we have to calibrate using field rut depth progression. Then only we will get the factuals. So from this, what is our expected outcomes? Clear distinction between subgrade induced rutting and bituminous layer rutting. A validated shear strength criterion for predicting rutting in BC DBM. A layer-wise rutting prediction model. Total rut is equal to rut in BC plus DBM plus subgrade. Recommendations for updating IRC 37 to include rutting check in bituminous layers, not just mixed tests. So what are the, now we'll see the potential contributions of this innovation or further studies. It will improve reliability of payment life prediction, reduces premature rutting failures on high volume highways, provides scientific basis for temperature, which we neglected, and traffic specific designs. It will bridge the current gap between mixed design and structural design approaches. Hence, further study beyond IRC 37 or to the IRC 37 of this version is needed because the above proposed framework combines field monitoring, lab tests, and mechanistic modeling to create a more robust rating criteria for bituminous layers. Thank you very much. I hope the research institutes can throw a light on the above issue. Thank you very much.